Good morning, students. In today's class, I will explain how we can overload binary operator in C++. When we were earlier classes, we learned about the different binary operators available in C++. All the arithmetic operators such as plus, minus, star, slash, they are all binary operators. Similarly, all the relational operators greater than, less than, greater than or equal to, less than or equal to, double equals to, not equal to, they are also binary operators. So all the arithmetic operator we can overload. Similarly, we can overload all the relational operator also. But as an example, as for illustrative purpose, in today's class, I will show how the arithmetic operator plus, minus, star, and slash can be overloaded to perform arithmetic operations on two different complex numbers. Complex number, we know it's not a basic data type in C++. Still, the operator plus can be used to add two complex number. Star can be used to multiply two complex number. Minus to subtract two complex number. And slash to divide two complex number. That means for these four arithmetic operator, which were generally defined to work with basic data type, like we can add two integer, we can subtract two integer, we can multiply two integer, and we can divide two integer or two real number also. They are basic data type, but same operator can be used to perform arithmetic operations on two complex number objects. So we are providing additional strength to the existing operator to behave in the same manner as that of basic data type. So that is the basic principle of operator overloading. In our last class, we learned about how unary operator can be overloaded in C++. As an example, I have considered the unary operator plus plus to find the next date. Here also, date is not a basic data type. That is also user-defined data type. Same plus plus operator can be either can be used to increment an integer number or can also be used to increment the date. And I've illustrated through the example of finding the next date by overloading plus plus operator. In today's class, I will be illustrating overloading of binary operator, especially the arithmetic operator plus, minus, star, slash for performing arithmetic operations on two complex numbers. At the end of today's class, you will be learning how the arithmetic operator in generally, how binary operator can be overloaded in C++. Let us take the program to perform arithmetic operations on two complex number by overloading plus, minus, star, and slash respectively. So here I will overload plus operator to add two complex number, overload minus to find the difference of two complex number, star to multiply two complex number, and slash to divide two complex number. In our first class on polymorphism, I explained whenever you want to overload any operator, equivalently we have to write one operator function. So in this in this program, what happens is we are overloading four different arithmetic operator. Means we have to write four operator function. Other characteristics of an operator function is operator function can be either a member function or it could be a friend function. In our previous class, while overloading plus plus operator to find the next date, I have made that operator function as a member function. But just for a change, I will illustrate how operator function can be made as a friend function. So here I will write all the four operator function for overloading plus, minus, star, slash as a member, not member function, but as a friend function. So the first three header files, the purpose you already know. Then you start with the class definition. Class, complex, private, float, r, comma, I. So r and I represent the real and imaginary part of the complex number. Both of them are float type and they are declared under the access specifier private. The first member function is read function, public, void read. Then the purpose of read function is to input the value for r and I. So C in r, I. So we have defined the first member function read. Next, second function. The second function, display function. The purpose is to display the given complex number in exactly complex number format. What is the general syntax of complex number format? A, that is real part, plus B, imaginary part, then I value. So any complex number has the format A plus IB. So I want to display it in that format. C out R. First to display the real part, then shift left, the double quote plus mark is there. So display the plus mark. then again shift left, then within the double quote you have the left parenthesis. So display the left parenthesis. Then within that one again shift left the value of I, imaginary value, then shift left again within the double quote, close the right parenthesis, then shift left I1. So it will exactly display it in A plus I within the bracket B. Then see, here I have written 4 different operator function: operator plus, operator minus, operator star, operator slash. So in order to overload plus operator, so here I have written all the operator function as a friend operator function. You already know the difference between writing an operator function as a member function as a friend function. In case of member function, to overload unary operator, no arguments are required. Whereas for friend operator function, one argument is must. Similarly, in case of binary operator, for member operator function, one object is enough. Whereas for friend operator function, you have to pass two parameters of two objects as parameters. So here, the first keyword friend indicates that your operator function is a friend function. Then the next word complex indicate the return type. When you add two complex number, definitely the result is another complex number. Means the return type is complex. The operator, the keyword is operator, which is the operator for addition plus. And then since you are writing the operator function is a friend function, you have to pass two objects as parameter. The first object is C1 of complex type. The second object is C2. Again, that is also complex type. Next three declaration similar. So friend, complex, operator minus complex C1 comma C2. For the third one, friend, complex, operator star complex C1 comma C2. Friend, complex, operator slash complex comma C2. Suppose instead of friend function, if I written this function as a member function, means the syntax would be first keyword friend is not required. So straight away complex operator plus within the bracket you have to give only one object, complex C2 or complex C1, that is left to you. Let us write the 4 operator functions one by one. For the first operator function, what is the return type? Complex. Which is the operator we are overloading? Plus. So operator plus. The two objects are complex C1 comma complex C2. We know how to add two complex number. In case of addition of two complex number, real part of the result, that is C3, equal to real part of C1 plus real part of C2. Similarly, imaginary part of C3 equal to imaginary part of C1 plus imaginary part of C2. So here the return object is C3. So you have to declare it inside the operator function complex C3. Now, when you look at this declaration, you can see C1, C2, and also C3. So all the three objects are visible. Means for every object, in order to access R and I, you have to use the dot operator. So C3 dot R equal to C1 dot R plus C2 dot R. C3 dot I equal to C1 dot I plus C2 dot I. Return the object C3. Same thing you repeat it for subtraction, minus operator also. The thing is, wherever plus is there, you have to replace it with minus. So complex C3, C3 dot R equal to C1 dot R minus C2 dot R. C3 dot I equal to C1 dot I minus C2 dot I. Return C3. So addition and subtraction of two complex numbers straight away. Very, very simple. For multiplication, the formula is different. Complex, return type is complex. Operator you are overloading is star, operator star, complex C1 comma complex C2. Then the return object is C3. So inside the function, operator function, you declare another object called C3. Then C3 dot R, that is real part of C3 equal to real part of C1, that is C1 dot R, into real part of second complex number C2 dot R minus C1 dot I, imaginary part of C1, into imaginary part of C2. Similarly, C3 dot I, that is imaginary part of C3, equal to imaginary part of C1 into real part of C2 plus real part of C1 into imaginary part of C2. This is a straight, this is a general and well established formula to find the product of two complex numbers. So return C3. In the case of division of two complex number, you have to rationalize the denominator. Anyway, you already learned in your second PU how to rationalize the complex number, etc. Complex return type operator slash complex C1 comma complex C2, then complex C3. First, you have to calculate a variable called denominator of float type. Denominator value equal to float deno equal to real part of C2 into real part of C2. That is C2 dot R into C2 dot R plus imaginary part of C2 into imaginary part of C2. C2 dot I into C2 dot I. Then C3 dot R, real part of C3 equal to C1 dot R into C2 dot R plus C1 dot I into C2 dot I divided by D now. Similarly, C3 dot I equal to C1 dot I into C2 dot R minus C1 dot R into C2 dot I divided by denominator written C3. So these two, multiplication and division, you have to remember the formulas. Whereas for addition and subtraction, it is straightforward. Now we have written 4 operator function for overloading plus, minus, star, slash respectively. And all the 4 operator function have written it as a friend function. Next, you write the main function. Void main, int choice. Here, we can perform the different operation by giving different value for choice. When you give choice equal to 1, you will get sum of 2 complex number. 2 means subtraction, 3 means multiplication, 4 means division, 5 means exit. So here we require 3 different objects, C1, C2, C3, complex C1, C2, C3. To clear the screen, enter the first complex number. In order to enter the first complex number, you have to call the read function with C1, C1 dot read. Similarly, enter the second complex number, call the same read function with C2, C2 dot read. Then the 4 messages, C1, 1 addition of 2 complex number, 2 subtraction, 3 multiplication, 4 division, and 5 exit. Then enter your choice, C in choice. So here you can give any values for choice. Switch based on the value for choice. When choice equal to 1, case 1, straight away you can write the statement C3 equal to C1 plus C2. When you look at the statement C3 equal to C1 plus C2, it looks like we are using such addition operator directly onto integer. But instead of that one, you are using the same plus operator in the same way as on object also. So C3 is not a integer type, C3 is not a float type also. C3 is what? C3 is an object. So the plus operator can be applied on 2 objects directly. That is the power of operator overloading. So C3 equal to C1 plus C2. When you add the 2 complex number, the result will be now available in C3. You display the third complex number C3. So C out, sum of 2 complex number is C3 dot display break. Next 4 choices are exactly similar. The formula is instead of plus, next time it is minus. So case 2 colon C3 equal to C1 minus C2, difference of 2 complex number, call the display function with C3 break. For 3, C3 equal to C1 into C2, product of 2 complex number is equal to C3 dot display break. And the fourth choice is C3 equal to C1 slash C2. Here division of 2 complex number is C3 dot display break. Case 5 means exit or break. And default, when you have given the value for choice other than 1, 2, 3, 4, 5, in that case, 1 means plus, 2 means minus, 3 means star, 4 means flag. If you give any other value, means the operator itself is not available, means it's invalid operator and also invalid choice. So exit 0, get choice. While choice not equal to 5, you have to repeat all these operations. So this is one simple example for input output. I have given the example how you should give the input and what is the output. Enter the first complex number. So I have given 3, 4. So 3 is C1 dot R, 4 is C1 dot I. So the complex number will become 3 plus 4I. Enter the second complex number 5, 1. That means second complex number will be 5 plus 1I. C2 dot R equal to 5, C2 dot I equal to 1. Next, there are 5 choices 1, 2, 3, 4, 5. Here I am giving the choice 1. So 1 means what operation? Addition. So when I add those 2 complex number, 5 plus 3, 8, and 4 plus 1 means 5. So the result complex number will be 8 plus 5I. That is displayed as 8 plus within the parenthesis 5 and outside the parenthesis I, because the display function is written like that only. Next, I already told you operator function can be written either as a friend function or as a operator member function. In the previous example, I have written all the 4 function as friend function. Now I will show how the same thing can be written using operator function, not as a friend function. So instead of taking all the 4, in the second example, I will consider only the 2 operations, addition and subtraction. The remaining 2, we can do it on your own. Class complex, private float r comma I, public void read. The purpose is remains the same to input the complex number C in Ri, void display, C out, or plus mark within the parenthesis I parenthesis mark, then I value, then again close the parenthesis, then I mark. Then here the word friend has to remove because this here I am writing it as a member function. So first you straight away go with return type. What is the return type? Complex. Which is the operator overloading plus operator plus into the bracket. Since you are overloading a binary operator using member function, one object is necessary. So the second object is C2. You can give only C2 or you can give C1 also, no problem. But only one of them should come here. Then complex operator minus complex C2. Next two you can write it on your own. Complex operator star complex C2. Complex operator slash complex C2. That you can do it on your own. Now you start with defining the operator function. So here I'm defining the member function outside the class. What is the general syntax of defining a member function outside the class? Return type, then the class name, scope resolution operator, then the function name, then you have to declare the argument. So here, what is the return type? Complex. Then to which class the operator function belong? That is also complex. So complex, scope resolution operator, the function name is operator plus. Then what is the argument you are passing? Complex C2. Since the function returns another object of complex type, you declare one more object C3 inside the operator function complex C3. So when you look at this declaration here, only the object C2 and C3 are visible. C1 is not visible. Hence, while accessing the any member data for C2 and C3, you make use of dot operator. For C1, directly we can access as R and I. So, how to add two complex number? Real part of C3 equal to real part of C1 plus real part of C2. Whereas for C1, dot operator is not required. So straight away you can write C3 dot R equal to R. Wherever I write simply R, it is for C1 only. So it becomes C3 dot R equal to R plus C2 dot R. Similarly, C3 dot I equal to I plus C2 dot I. Only for C3 and C2, you have to make use of dot operator. For C1, straight away you can access R and I. Return C3. Same thing, you return it for second operator function. Return type is complex operator. Oh, here also I made, here also you have to add the word called complex scope resolution operator, then operator minus. So that word complex, one more complex and the scope resolution operator is missing here. You just add it. So first keyword is complex. Second keyword you should add is complex because you have to indicate the class name also, complex scope resolution operator, then operator. The operator here you are overloading is minus. In the bracket you write complex C2. You make small changes there. Then object is return object is C3. Same thing. C3 dot R equal to R. R means C1 dot R minus C2 dot R. C3 dot I equal to I minus C2 dot I. Return C3. So this line you have to change it like this. After the first complex number, you add one more complex. Add the word called complex. Then scope resolution operator. Then start with operator minus. Just similar to previous function. The previous function, it is complex scope resolution operator plus complexity. Same thing you repeated here also. Complex scope resolution operator minus complexity. You have to make the changes. That word complex and scope resolution is omitted here. That's a mistake. So today I have illustrated two major concepts here. How to overload binary operator, and that too, how to write the operator function as a member function, as well as how to write it as a member as a friend operator function. And I have considered to illustrate the concept, I have taken the example of overloading plus minus star slash for performing arithmetic operations on two complex number. In the previous example, here I have written I have overloaded only two operator plus and minus. You can continue with overloading other two operator also, that is star and slash. So while defining the operator function for star and slash and slash, the changes is like this. For star operator, return type is complex. The class it belongs, complex only. Scope resolution, operator, star. Inside the bracket, you have to write it as complex C2. Again, within the parenthesis, complex C3. So here also same thing. The statement is becomes like this. C3 dot R equal to, wherever C1 is there, you just remove the word C1. It simply become C3 dot R equal to R into C2 dot R minus I into C2 dot I. Again, C3 dot I equal to I into C2 dot R plus R into C2 dot I, return C3. Similarly, for division, return type is complex, class name is complex, complex, scope resolution, operator, slash, in the bracket, complex C2. So, complex C3, float deno equal to C2 dot R into C2 dot R plus I into I into I. Not I into I, become C2 dot R into C2 dot R plus C2 dot I into C2 dot I for deno. Whereas for C3 dot R, it becomes R into C2 dot R plus I into C2 dot I divided by deno. C3 dot I equal to I into C2 dot R minus R into C2 dot R into C2 dot I divided by deno. So wherever C1 is C1 dot something is there, you simply write R and I. For C1, don't use dot operator. So some of the review questions on today's concept is, mention any 4 binary operator that can be overloaded. All the arithmetic operators are binary operator. All the relational operators are binary operator. You can mention any 4. Illustrate with an example, overloading any 2 binary operator. So here I have illustrated with 4 binary operator. Either you can explain with any 2 binary operator. Write a C++ program to overload plus, minus, star, and division slash to perform arithmetic operations on 2 complex numbers using member operator function. So in the second example, I have illustrated overloading plus and minus using member operator function. Remaining, that is star and slash, you can write it as a member operator function. Some simple multiple choice questions are, to overload a binary operator, friend operator function takes how many arguments? Friend, if it is a friend operator function, for binary it takes 2. Whereas for member operator function, it takes only 1. The correct answer is 2D. In case of binary operator overloading, member operator function takes only 1 argument. The correct answer is B. Which of the following is not a unary operator? Plus plus, unary operator. Logical not, exclamatory mark, that is also unary. Complement, that tilde mark, that is also unary. Comma operator is a binary operator. The correct answer is D. To compare 2 strings, which operator to be overloaded? How you can compare 2 integer? If A double equals to B, same operator you can use it to compare 2 strings also, because C++ in the operator overloading concept, it never differentiate between basic data type and user defined data type. The operator is double equals. Whereas to concatenate 2 strings, to join 2 strings, operator to be overloaded is plus. So here the correct answer is double equals B. Identify the wrong statement. Friend operator function is defined outside the class. True. Operator function may be defined outside the class. That is also true, because if it's the operator function, you can define it either inside or outside. Greater than operator can be used to compare 2 dates by overloading greater than operator. True, because greater than operator is for comparison. Whether it is you are comparing 2 integer or you are comparing 2 dates, doesn't make any difference. Friend operator function may be defined inside the class. No, friend function, whether it's an operator function or a normal function, it has to be defined only outside the class, because friend function never comes within the scope of the class. So students, in today's class, I have explained with a example program on how binary operator plus, minus, star, slash can be used to perform arithmetic operations on 2 complex numbers. In addition to that one, I also explained how the operator function can be written as a member operator function and as a friend operator function. In case of friend operator function, I have overloaded all the 4 arithmetic operators. Whereas in the case of operator function, I have illustrated with only overloading plus and minus, but remaining 2, you can do it on your own. It's very, very simple. With this, I will wind up today's class. Thank you.